Good day, guys. You're welcome to Neuroanatomy Zone. This where we study neuroanatomy in a very simplified format. I'm Max from Neuroanatomy Zone. I'm your host for today. Today we'll be looking at the embryonic development of the nervous system. How did the nervous system come about? Okay, how did the whole process of you have a brain? How does the brain develop? How does the whole structures of the that made of nervous system are developed while we were still in our mother's womb? Okay. So first, let's get right into it. Yeah. The process of the development of the nervous system begins at about 3 weeks of intrauterine life. Okay. Through a process that is known as neurulation. You know, after the process of gastrulation, whereby the embryo become divided into 3 germ layers, that is the ectoderm, the mesoderm, and the endoderm. Immediately after that process of gastrulation, the process of neurulation begins. Now, neurulation is the process whereby the nervous system is being developed. And the nervous system is developed from the embryonic ectoderm layer. Okay, the ectoderm became the skin, the nervous system, and probably the vertebrae. Okay, the vertebrae, and then anything that have to do with neuronal connection. Okay, the mesoderm became the muscles and organs, and the endoderm became the digestive tract, and then the associated digestive organ, that is the liver. Okay, now the process of gastrulation begins at 3 weeks of intrauterine life. Okay. The process of gastrulation is being instigated into place by a structure known as the noctocord. Now, the noctocord is an embryonic structure. You cannot find it in the adult human, in the adult human being. Okay. But you can find it in the embryo. The function of the noctocord is to stimulate the process of neurulation. Okay. What happens is that for the whole process, for the whole nervous system to be developed, you need a structure known as the neural tube. Okay, it is the neural tube that will become modified to form the central nervous system. Okay, so the noctocord will stimulate the formation of the neural tube. After the formation of the neural tube, when the formation of the neural tube is complete, the noctocord will dissolve. It will disappear. Okay. Now, the formation of the neural tube. Okay. The neural tube, the formation of the neural tube begins at about 3 weeks of intrauterine life. Okay. Now, it is stimulated and directed by a structure known as the noctocord. Now, the noctocord is an embryonic structure. Okay. Very embryonic structure. That's this dot that you can see here. Okay, this is the noctocord. Now, this is the embryonic ectoderm layer. Okay, remember at this stage the embryo have 3 layers. Okay, we have the ectoderm. Here will be the endoderm, and then here will be the mesoderm layer, and then here will be the endoderm layer. Okay, the endoderm becomes the digestive tract. The mesoderm becomes the muscles and organs, and then the ectoderm is what the nervous system is going to be formed from. Now, what happens is that the noctocord will begin releasing some proteins, chemotactic proteins, that are known as sonic hedgehogs, SHH proteins for short. Okay, SHH proteins for short, sonic hedgehog. These chemotactic proteins will be released by the noctocord, okay, and they are consecration dependent. So this sonic hedgehog will cause a thickening of the portion of the embryonic ectoderm layer that is closest to the noctocord. Okay, this thickening will result in the formation of a structure that is known as the neural plate. Okay, so this is going to be the neural plate. Okay. Next, after the formation of the neural plate, with the subsequent release of SHH proteins from the noctocord, the newly formed neural plate will start involuting inward. It will start invaginating inward. Okay, as it continues invaginating inward, it forms the structure known as the neural groove. Okay. What the neural groove is trying to do is that it's trying to touch the notochord, but the notochord will never let it touch it, okay? It will keep releasing chemotactic SHH proteins that will keep stimulating the involution and invagination of the neural plate, okay, forming the neural groove, okay? Now this neural groove is going to continue invaginating inward. It's going to continue invaginating inward. Okay? It's going to continue invaginating inward until both ends of the neural groove will coalesce together. Coalesce meaning they're going to touch each other. They're going to coalesce together. After the coalition of both ends of both corners of this neural groove, a tube-like structure will be formed, and then it is this tube-like structure this newly formed tube-like structure that is referred to as the neural tube. It is this neural tube that's going to be modified and further developed to produce the brain and the spinal cord. Okay? Now, the remaining corners, the remaining structures of the neural groove and the neural plate are going to form what we call the neural crest. And the neural crest are going to be further developed to produce the cells and structures that made up the peripheral nervous system. Okay? This neural crest, they are going to be further developed to produce the structures that make up the peripheral nervous system and even the vertebrae that protects the central nervous system. Okay. Now that the neural tube has been formed, the notochord will then disappear, it will then dissolve. Okay. That's why you can find the notochord in the adults. After the formation of the neural tube, after the neural tube has been formed, the neural tube will be further developed to produce the brain and the spinal cord. Okay? Now, at day 23 and day 24 of intrauterine life, the cephalic end, that is the superior end of this neural tube, will seal up. Up to this time, both ends of the neural tube has been opened, so the amniotic fluid that bathes us, that houses us while we are still in our mother's womb, will actually be flowing through the neural tube up to this point. Okay? So the superior end of this neural tube is known as the cephalic end. Okay? It's called cephalic end. Okay? While the inferior end is known as the caudal tail. Okay? The caudal. At day 27 of intrauterine life, the caudal tail of the neural tube will seal up. Okay? Immediately after the sealing of the cephalic end and the caudal tail, the cephalic end of the neural tube will undergo a process known as the cephalic expansion. Okay? Forming an expanded structure. Okay? So you see, this expanded structure is known as the encephalic expansion. Okay, so you could see the cephalic end of the cephalic head of the neural tube expanding here to form the encephalic expansion. Okay, and then you have the caudal tail remaining as it is. Now, after the encephalic expansion, immediately after the okay, will undergo further division to become divided to form 3 primary vesicles of the brain. These 3 primary vesicles of the brain are 1. Prosencephalon. Okay. 2. mesencephalon. And 3, rhombencephalon. Okay. After this first division to produce the 3 primary vesicles of the brain, these 3 primary vesicles of the brain will undergo further development and division to produce 5 secondary vesicles of the brain. So we have what happens is that the prosencephalon will become divided into 2 to produce telencephalon and diencephalon. The mesencephalon is going to remain as it is, okay? It's going to be what will become the midbrain. And then the rhombencephalon is going to divide into 2 to produce metencephalon and myelencephalon, okay? I will explain what I just said in a moment, or what I just said in a moment. Now, I said first we have the encephalic expansion, and then the expanded encephalon divides to produce 3 primary vesicles of the brain, and then these 3 primary vesicles of the brain further divide to produce 5 secondary vesicles of the brain. These 5 secondary vesicles of the brain are as a result of 1, the telencephalon dividing into 2 to become telencephalon and diencephalon. Telencephalon is just another word for the cerebral cortex, okay? The cerebral cortex, okay? Where you have a lot of gray matters. Diencephalon is another word for the inner layer of the cerebrum, where you have a lot of nuclei, where you have a lot of white matters and nuclei like the thalamus, methythalamus, subthalamus, epithalamus, hypothalamus, and all those nuclei, including the basal, majority of the basal nuclei of basal ganglia. Okay. The mesencephalon is going to remain as it is. The mesencephalon is going to become the midbrain. And then the rhombencephalon is going to divide into 2 as well to produce metencephalon, which comprises of the pons and the cerebellum, and myelencephalon, which is what will become the medulla oblongata. Myelencephalon is the Latin word for myelon is the Latin word for spinal cord. Okay, so myelencephalon means encephalon is the Latin word for brain. Myelon is the Latin word for spinal cord. So myelencephalon meaning spinal cord, the part of the brain that is closely connected to the spinal cord. That's the meaning of the word myelencephalon. Okay, encephalon means brain and myelon means spinal cord. Okay, so from what we just seen, we'll see that we'll have a complete. The neural tube has given us a complete central nervous system, which is the brain and the spinal cord. Okay, but during all this development, remember, after the formation of the neural tube, it was a hollow tube, right? It was a hollow tube, and then the encephalic end seals up, and then the caudal tail also seals up. But I never told you that the inside sealed up, because the inside never sealed up. So the inside is still hollow. It's just like a hollow box, like a hollow cylinder, okay, like a hollow container, like a bucket. So the inside is still open, it's still very much open, okay? Because the inside is still very much open, there is a vesicle. So there's a vesicle inside this neural tube or inside this central nervous system that has just been formed. This vesicle never seals up, okay? Because this vesicle is going to be developed to produce what we call the ventricles of the brain. Okay, so the vesicle of the prosencephalon, the vesicle of the telecephalon is going to be developed to produce the right and the left lateral ventricles of the brain, while the vesicle of the diencephalon is going to be developed to produce the third ventricle of the brain. Okay, and then the vesicle of the mesencephalon is going to be developed to produce the cerebral aqueduct of Sylvius, which connects the third ventricle to the fourth ventricle. And then the vesicle of the rhombencephalon, the whole of the rhombencephalon, that's both metencephalon and myelencephalon, is going to form the fourth ventricle. Okay? So you see, the vesicle of the telecephalon forms the right and left lateral ventricles. The vesicle of the diencephalon will form, the vesicle means the hollow structure of these things, the hollow inside of these structures. Okay, the vesicle of the diencephalon becomes the third ventricle. The vesicle of the mesencephalon becomes the cerebral aqueduct of Sylvius, which will connect the third ventricle to the fourth ventricle, and then the vesicle of the rhombencephalon will form the fourth ventricle. Okay, and what these ventricles do is that they produce and direct the flow of cerebrospinal fluid. Okay, right. So that is that for embryonic development of the brain. But quickly before we go, I want to show you something. A summary of the whole process of neuralization. The whole process of neuralization can be summarized into this diagram, as you can see here. Okay, the summary of the whole process. You could see we have this encephalic end, as I've shown you. It becomes expanded, and then after to form this encephalic expansion, the encephalic expansion further undergo further development to produce the three primary vesicles of the brain, which are prosencephalon, mesencephalon, and rhombencephalon. And then these five primary vesicles undergo further development to produce the five secondary vesicles of the brain, which are telecephalon, which forms the cerebral cortex, the diencephalon, which forms the inner layer of the cerebrum, and then you have the mesencephalon, which becomes the midbrain, the metencephalon, which became the pons and the cerebellum, and then you have the myelencephalon, which becomes the medulla oblongata. So you could see you have prosencephalon became telecephalon and diencephalon, okay? And then the structures that can be found in the telecephalon, the cerebral hemisphere, and the corpus striatum, okay? And then the cavity of the telecephalon became the lateral ventricles, the right and the left lateral ventricles. The diencephalon becomes the inner layer of the cerebrum, where you have a lot of nuclei like thalamus, hypothalamus, pituitary gland, hypothalamus, subthalamus, epithalamus, and so on and so forth. And then the cavity of the diencephalon becomes the third ventricle. Okay, so the mesencephalon remains as it is. It becomes the midbrain. Okay, in the midbrain, that's where you have the substantia nigra, which is one of the basal nuclei, or basal ganglia. Now, the cavity of the mesencephalon becomes the cerebral aqueduct of Sylvius. Okay, now the rhombencephalon would undergo division to become the metencephalon and myelencephalon. The metencephalon becomes the pons and the cerebellum, and then the myelencephalon becomes the medulla oblongata. Now, the cavity of the rhombencephalon becomes the fourth ventricle. Okay, so with that, I want to say thank you for watching. As always, stay tuned for more. Don't forget to like, click the notification button, the notification bell, so you'll be informed when each time we upload a new video like this. And then don't forget to share. Okay, like, click the notification button and share. Talk to your friends about us. Okay, I hope you've learned a lot from here, from this video. Thank you.